Some practice here for how to simplify radicals. So what we have is I got a square that is 12 units by 12 units, and I'm going to try to figure out what is the distance on this diagonal. So I'm going to use Pythagorean theorem for that. We're going to use like this triangle right here, and so to do that we're just going to set up the Pythagorean theorem. Here is the actual formula, and what I will have is, because both a and b are 12, we'll have 12 squared plus 12 squared equals c squared. Each of these is going to be 144, and the c squared is going to be 288, and c, of course, will be the square root of that. So c is going to be equal to the square root of 288 units. And that is this distance right here. Okay, so that's just using the Pythagorean theorem. What I really want to do though is I want to simplify this, because this is not as simple as it could possibly go. So I need some factors. Here are all of the factors of 288, and there are a lot of them. But what's nice about this is actually I'm looking for pretty specific factors. And I'll show you what I mean by that. If I were to use, let's say, 3 and 96, we're going to take our square root of 288, and we want to split it up into different factors. So if I split this up as 3 times 96, which I sure can do because we've got 396 is 288, so I've just replaced things. This is a true statement. The problem is that there's really nothing that I can do with the 3 and 96 as they are, because the square root of 3 is an irrational number. It's about 1 in 7300ths, but continuing on here, square root of 96 is about 9 in 7900ths, but both of these are irrational numbers, so this isn't really going to help me a ton. So let's get rid of those. And what we're looking for, so this one not super helpful, is we're looking for numbers where I have a perfect square. So what are the perfect squares? Well, here's a list of them. It's really just when you take integers, so whole numbers, and you square them. And the reason that we like the perfect squares is because they work out really nicely. Like the square root of 36 is 6. So actually, if I were to use this one instead, and instead wrote square root of 288 is the same as the square root of 8 times 36. This time, if I break this up, I'm going to get the square root of 8 times the square root of 36. Well, the square root of 36 is 6, and then I can just multiply that by the square root of 8, and then just because I can, a times b is the same as b times a, like 2 times 3, 3 times 2. So I rewrite this as, 6 square root of 8. Okay, so this is a simpler version, or at least another version of the square root of 288. These two things are equal. The trick is that I can still break up this 8, because I could break the 8 into 2 times 4, and then I could break that up. So this is actually, if I take the square root of this, I get square root of 8 is the same as 2 root 2, because the square root of 4 is 2, and then I've got a root 2 still, so like it's not totally done yet. You can get there this way, but if you have all of the factors here, what you're looking for is where are the perfect squares. So let's identify those first. They are 144, 36, 16, 9. All of those work, but what we're looking for is we're looking for the largest one, which is really going to be 2 times 144. So if we instead write this all out as square root of 288 is equal to the square root of 144 times 2, then I can split this up as the square root of 144 times the square root of 2, and the square root of 144 is going to be 12, so 12 root 2. And because I cannot break 2 up anymore, there's no factors of 2 that I still pull out, this is going to end up being the most simplified form of this radical. If you're feeling good about this, you can pause the video here. If you are like, whoa, that was really fast, I'm going to do one more example for you, okay? Okay, our goal here is going to be to simplify the square root of 108. So the first thing that I'm going to need is I'm going to need the factors of 108. So here are all of those factors, and then as I'm looking through the factors, the only ones that I'm really going to care about are the ones where I actually have a perfect square. So 36 is a perfect square, 4 is a perfect square, 9 is a perfect square, and none of the other numbers here are perfect squares. So I could break 108 up and say the square root of 108 is the same as 3 times 36. I could also say square root of 108 is the same as 4 times 27. I could also say 108 is the same as 9 times 12. Now, if I start breaking these apart, well, the square root of 4 is 2. So in this case, I'm going to get 2 square root of 27. The square root of 9 is 3, so I'm going to get 3 square root of 12. In this case, I'm going to get square root of 36 is 6, so I'm going to get 6 square root of 3. And again, what you wanted to pick really is the biggest one, so this is going to be our most simplified version. And the reason is that there's still a perfect square in the factors of 27. There is still a perfect square in the factors of 12. So I could rewrite this one. I could write this as 2 square root of 9 times 3. And then I would end up getting 2, and then the square root of 9 is 3 times 3, square root of 3. This one I could also break up. This is 3 times the square root of 4 times 3. Square root of 4 is 2, so I'm going to get 3 times 2 square root of 3. And check it out, once you've broken everything down, so you can get there this way, it's just a little bit longer. 2 times 3, that is just 6 square root of 3. Again, 3 times 2, that is 6 square root of 3. So no matter what you do, you end up with the most simplified version of this is going to be 6 square root of 3. It just saves you a lot of time if you can find the largest perfect square that is a factor of the number that you're breaking apart. Hopefully that answered some questions. Please let us know if you have more of them. We will be super happy to help out.